Dear students, today I am going to explain about joint dependencies and fifth normal form. In the previous class, we have discussed about multi-value dependencies and fourth normal form. Okay, so and also we have seen the functional dependencies in we have explained with the help with the when we are defining first, second, third, and fourth normal, second, third, and BCNF, Boyce code normal form. Okay, so now we are going to discuss first joint dependency, then we are going to define fifth normal form using joint dependency. So first we will define joint dependency, that is called as JD, denoted by JD of joint dependency of R1, R2, Rn, R1, R2, etc. Rn are the relations, okay, relation schemas specified on relation schema or specifies a constraint and the state R of R. So when we are specifying the constraint, we are specifying the constraint and the states R of R. The constraint states that every legal state R of R should have a non-additive joint decomposition into R1, R2, etc. Rn. That is, every such R we have, every relation set R we have, that is star pi R1 of R, that is R1 of R is this R is the relation state of R1. The valid relation state of R2, this is called as valid relation state of Rn, that is equal to R. Okay, then and also we should know that multi-value dependency is a special case of joint dependency if n is equal to 2. Okay, that is the thing. So the joint dependency JD of R1, R2, etc. Rn specified on the relation schema R. Okay, is a trivial joint dependency if one of the relation schemas Ri in JD of joint dependency of R1, R2, etc. Rn is equal to R. That is also possible. One of the relation schemas in Ri, they may be equal to R. Either it may be R1, R2 or R3. Anything may be equal to R. That is also possible. Okay, so that we now will define that fifth normal form. So how we can define means the relation schema R is in fifth normal form 5NF. Otherwise it is called as project joint normal form PJNF, project joint normal form, with respect to a set of F of functional, multi-valued and joint dependencies if. Okay, so now you should remember when we are defining the second normal form, third normal form and BCNF, we have considered only the functional dependencies. When we are defining the fourth normal form, we have taken functional dependency and multi-value dependency. Now when we are defining the fifth normal form, we should take that account into functional dependency, multi-value dependency and joint dependency into account. Okay, for every non-trivial joint dependency, JD of R1, R2, etc. Rn in F plus, okay, the F plus already know a closure of F. Okay, so that is if for every Ri is a super key of R, every Ri, R suffix I is a super, that is every R1, that is R1 is a super key of R, R2 is a super key and so on. Okay, that should be there. So this is a fifth normal form. Then discovering joint dependencies in practical databases with hundreds of relations. Suppose we are having joint dependency with R1, R2, etc. R100 is there, means it is impossible to make it. Okay. So that's the reason fifth normal form is rarely used in practically. Okay, theoretically we are studying, we are explaining, but rarely it is used in practically. Now up to third normal form, sometimes up to fourth normal form, it is applicable for all the relations. But some relations with this having more number of sub-relations, then it is difficult to apply this fifth normal form, and so it is not used in practically. So for example, here we will take supply. This relation you will take, this is in fourth normal form but not in a fifth normal form due to joint dependency. So here we will take this one separately. If we will take this, we will split into this, decompose this relation supply into the sub-relations, S name and part name. S name and part name, and then S name and project name, and then part name and project name. All three separate relations will make it, decompose it, then the relation is in a fifth normal form. Okay, now we are going to join these relations R1, join dependency of R1 comma R2 comma R3 equal to the supply. Okay, relation R, that is supply. Okay, so the joint dependency involved over here, so that is joint dependency of R1 R2 R3 is equal to supply. Okay, that is the thing. So like this we can make it for joint dependencies and the fifth normal form definition. Then this is for in general. Now already we have seen all the normal forms 1, 2, 3 and BCNF, fourth normal form and fifth normal form. Now we'll see that the various steps in that one overview. So that table with multi-valued attributes means, so if we'll remove that multi-valued and composite attributes, the nested relations, then the relation will be in a first normal form. So then after that, if we'll remove partial dependencies, then it will move into second normal form. Then in the second normal form, if it is there any transitive dependencies, we'll remove it, it will enter into third normal form. So in the third normal form, we are going to remove remaining anomalies resulting from the functional dependencies, then it will enter into Boy's code normal form or BCNF. So in that, then next again if any multi-value dependencies are there, that will be removed, means it will enter into fourth normal form. Then in the fourth normal form, when the relation is in fourth normal form, in that we are going, if any joint dependencies are there, remaining anomalies and joint dependencies are there, we are going to remove it, means that relation will enter into fifth normal form. Okay, so this is the various steps of normalization process. So that's all about the main normalization process steps. Then next we are going to see the algorithms, the inference rules, how it will be used, then how to find out the closure, then minimal cover and so on in the next topics. Okay, thank you.